dan salam sejahtera. So for this video, we will discuss tutorial number 2, which is capacitor and dielectric. So I will divide this tutorial to 2 parts. One, for the first part, maybe I think we discuss question 1 until 10, and then the next video we discuss question 11 until 15. Okay, you can start straight away to the objective question. So remember, before you guys watch this video, make sure you guys already tried to do the tutorial yourself, and make sure you guys already watch all the previous video on this chapter. I think about 4 parts. So this one will be the 5th, and then the next one will be 6th. Okay, which one of the following changes will necessarily increase the capacitance of the capacitor? So has some answer decreasing the charge on the plates. That one doesn't necessarily increase the capacitance. So if you want to change the capacitance, you can change the dimension, the physical dimension of the capacitor, like the size of the area, the distance separation D, or in this case they actually insert a dielectric between the plates. So that one, the answer should be C lah. So when you insert, then you will have equation of C equals to epsilon R epsilon naught A over D. So basically you are changing the epsilon R. Okay, for question number 2, an initially uncharged parallel plate capacitor of capacitance C is charged to potential V by a battery. The battery is then disconnected. So initially you have a power supply, then the power supply is removed. Which statement is correct? Okay, the answer would be the capacitor can be discharged by grounding any one of its 2 plates. So you can imagine that when the power supply is connected, then the capacitor is being charged, and then when it is disconnected, once you grounding or you connect it to a circuit, then it becomes a discharging capacitor. Okay, question number 3. A capacitor normally consists of 2 conductors separated by dielectric. The capacitance of such capacitor will depend on the geometrical dimension of the capacitor and the distance between the conductors. So the capacitance, it really depends on the dimension of the capacitor. Question number 4, when a dielectric with constant epsilon is inserted between the plates of a charged isolated capacitor, so the answer would be the electric field between the plates is reduced by a factor of epsilon. So this one is actually, you can imagine from our lecture, if you guys still remember, we have a dielectric materials that consists of molecules that can try to polarize ataupun arrange itself so that it will try to block some of the electric field. If you guys still remember my drawing lah. Okay, question number 5. The capacitance of capacitor is not affected by thickness of plate. So A, that one is D, I mean the distance D. So this one is D, so it affect the capacitance. A affect, all of them is wrong lah. So yeah, the answer would be B. Okay, moving on to question number 6. When a potential difference of 24 volt is applied across a capacitor, the charge on the capacitor is 120 microcoulomb. So the first thing that you want to do is you want to redraw, or you have to draw the circuit so that you can imagine what's the situation like. So what is the capacitance of the capacitor? So they give you Q and V. So straight away you know how to find C equals to Q over V. Okay. And then just press your calculator. B, the potential difference across the capacitor is then increased. How is the charge on the capacitor affected? So the V now increase. Now they just wanted to find the relation. So if the V increase, the capacitance of the charge will increase as well. Sorry, the question state when the charge is increased. Sorry, when the potential is okay. When the V is increased, Q increase. So you have equation C equals to Q over V. Rearrange, it become Q equals to CV. C is constant. Remember that C is constant. So Q is directly proportional to the V. So V increase, Q increase. The capacitance is not affected by the potential difference. So it does not affected by the potential difference increases. It depends on the dimension. Let's say if the parallel plates now increase the distance and then you or insert the dielectric materials, then only you can have change in capacitance. Question number 7. 3 6 microfarad capacitor are connected in parallel across 6 volt battery. Calculate C equivalent, total charge delivered by the battery. So draw the circuit. So this is a circuit that shows 3 parallel plates, 3 parallel capacitance. Each one of these has the same value, 6 times 10 to the power of negative 6. It is then connected to 6 volt. If you want to find equivalent capacitance, or normally we call it one as C effective, for parallel, we just have to add. Simple as that. Okay, C1 plus C2 plus C3, and then you get 18 microfarad. Yes. Question number 2, the total charge delivered by the battery. So you can imagine that if I want to find total charge, it's basically the charge that coming out on from here, like this. So I want to find my Q naught. So if I want to find my Q naught, I have to use equation of C naught, or C effective in this case, equals to Q naught over V naught. So you can imagine, if you want to find total charge, you have to use C effective and V of the power supply. So everything must be maximum. Something you can think something like that. So the answer would be 108 microcoulomb. So don't get confused with the unit of capacitance and charge. So sometimes in exams students got confused. 7b. 2 capacitors of capacitance, this one question 7. C1 and C2 are connected first in series and then in parallel. So initially it is in series and then in parallel. And the effective capacitance of the series circuit is 2 farad and the parallel is 9 farad. What are the values of the capacitance C1 and C2? So they just give you C1 and C2. They didn't give you any values, but they did give you the effective capacitance when it is in series and when it is in parallel. So first thing first, redraw the circuit. So initially you have series, finally you have parallel. So the first thing that you need to do is that you actually have to write down the equation like this. Oops. So if I have capacitors in series, if you want to calculate C effective, because you want to relate the value that is given, which is 2 here, you have to add 1 over C1 plus 1 over C2, like this. Okay, so basically over here I just cross multiply, samakan penyebut. C2 I bring over here, C1 over there, so it becomes C2 plus C1 over C1 C2. And this one I just substitute C effective with number 2, because the question state that the effective capacitance for series is 2 farad. So I leave that one first over there, and over here, so as I write this one as initial and final, so have 2 cases. For parallel, if I want to find C effective, I just have to add those C1 and C2. Okay, and then that one is actually equals to 9. Okay, this is my equation 2. That I think for the parallel is the first one. Okay, anyway. Okay, now I have my equation just now. I just bring it over here. I leave it like that. And then notice that equation number 2 actually is C1 plus C2. So I can substitute here inside the first equation here. Okay, so it becomes 9 over C1, C2, like this. And I can cross multiply. I bring it over here and I bring it over there. I got 18 equals to C1, C2. Okay, now I can substitute either C1 or C2 inside here. Okay, in this case, I show you actually I substitute 9 minus C1. That means I substitute C1, sorry. So if I substitute C1, 9 minus C2, I rearrange this one. So this one actually becomes C1 equals to 9 minus C2. And this is the equation that I substitute inside here. I got 9 minus C2. And then I just open up the bracket. Okay, over here I got quadratic. Now you can solve using calculator yourself. And make sure you know how to solve quadratic. Or else you can factorize like what you normally did. That one C minus 6 and C minus 3. So C2 could be two number, 3 and 6. So you have to consider both. And if C2 is 3, C1 is 6. I just basically substitute back inside this one question here. If C2 is 6, C1 is 3. So again, in exam, you just have to write all the answer. Don't have to choose ke apa ke. Itu dia je. Question number 8. Calculate the equivalent capacitance of the arrangement of capacitor shown in figure 2.1. Okay, so normally in exam, the question wouldn't be straightforward lah. Dia takkan straightforward. So what they might ask is that they try to complicate things by putting combination of series and parallel in one circuit. But don't worry. To answer it, you just have to do step by step. Okay, so in this example, you have 4 capacitor. You just have to do it one by one. So in this case, you can see clearly, if I want to solve, I can solve this part here first. So that if I combine these two, I got one capacitor. And then all these 3 capacitor will be in series. So that's the idea how you want to solve it. So the first step, do that one first. The second step, do this one. Okay. So step 1 is basically 5 and 4. Because that one is just a parallel. This is the first step. Because this one is just a parallel. So I can simply add. I got 9 microfarad. And then you can redraw. You have to redraw. I strongly suggest you to redraw. Now it becomes something like this. So this one is much simpler form. So every time you get a question, you get complicated circuit and you try to simplify it one by one. And every single time you simplify it, I strongly suggest you to redraw. So that you can see how easy it is. Okay, step number 2. Now you just have to combine the 3 capacitor which is in series. That one just 1 over, 1 over, 1 over. Press your calculator. Don't forget to inverse the C effective. There's 1 over C, right? So don't forget lah. Normally student will forget that one. Question number 9. Okay, this one one of the common question as well. So they give you in something like a real life situation where you have a circuit with a power supply, a working circuit. The 3 capacitors, they give you all the values connected in circuit as shown in figure 2.2. Calculate the equivalent capacitance. So this one is actually quite easy. You can solve it directly. But again, I strongly suggest you to redraw. This one, actually this method applied for this chapter and the chapter of resistor. So you try to simplify the circuit here. I can redraw it. So this one is actually exactly the same like this one. Actually this one, but if you draw it like this, you can see straight away how to solve it, because you have a parallel capacitor. Solve that one first and then you just combine these two which is in series. When you try to redraw, the method to redraw, okay, listen here carefully. If you want to redraw, you go from one side of the power supply. Normally I would go from the positive terminal and then I see a capacitor. So when you try to redraw, you draw it like that as well. So positive terminal, you see one capacitor, that one is C3, and then from the other side of the capacitor, it made a junction. So you need to know what is junction. So junction, when you have one circuit and then it becomes two. So you have a junction. This is basically a junction, and this junction, redraw it like this, like a T junction. Instead of like this, draw it like a T junction so that you can see clearly that this one is a parallel. The capacitor C2 and C1 is actually parallel to each other. Okay, the red junction, and I go through C1 down here, and then I go through up there, go through C2, and then it combine back at junction yellow here. Okay, and goes out, and then go back to negative terminal. So this is how you redraw the circuit. Make sure you familiarize yourself with this method. If you can familiarize, for me, chapter 2 and chapter 3 will be so easy. Every time once you redraw, you can double check. Make sure the numbers of junction is tally. So here you have two junction, red and yellow. Same with the initial one, red and yellow. If you redraw and suddenly you got 5 junction, then something is wrong. Numbers of capacitor, okay. And when you redraw, the most common mistake would be the labeling of C. So sometimes students accidentally write this one as C2 or C1 over there. So that one, they mix up everything. That one is wrong. Every time you redraw, you double check. Okay, then once you redraw, that one is easy. Okay, like I told you, solve this one first and then that one. So this one is so obvious. Could be charge on each capacitor. Okay, this one actually you have to think a little bit. So you want to find Q at C3, C1, and C2. And you need to realize the behavior of a charge is that as long as it is in the same circuit, I mean in the same line where they didn't go, the charge didn't go through any junction, the charge will remain the same. So maksudnya kalau charge tu tak lalu apa-apa sempang, the charge tu sama je. So in this case, every time the question want you to find every time the question want to find charge on each capacitor or voltage at each capacitor, the first thing that you might have to do is that you have to find the Q0 first, total charge on the circuit. So that one is actually the charge delivered by the power supply here. So it goes out. How to find that one? You have to use Q0 and V0. So you still have use C equals to Q over V, but remember, if I want to use Q0, the partner would be V0 and C effective. Since I have 1 to 3, I just write this one is 1 to 3, but this one is actually C effective. So that one represents the charge coming out from the battery. So actually the direction of Q will be in this direction. So I redraw it here. But for the sake of understanding the question, then I think this one is okay. Okay, so if I have my Q0 in this circuit, over here the value will remain the same, and then it meets up a junction separate. So if you have equal resistor or equal capacitance value, the charge will separated exactly half. So that means if I have 10 coulomb, over here it becomes 5 and 5. So if this one is not balanced or it's not the same, then obviously you have a little bit more on one side and a little bit less on the other sides, like 6 and 4. This is just an example. Now when it combines back, the charge will combine again. So this one over here, it becomes Q0 again. And in my example just now, it becomes 10. And go through another capacitor, so that one will be Q0. So if I want to find the charge on each capacitor, straight away I know that Q3 is actually equals to Q0, which is in this case 7.5 times 10 negative 6. Okay, what is this? Okay, once I found my Q3, so actually I didn't write over here. Yeah. Okay. Okay, so you have to watch it again. So over here actually, well, okay, so Q0, I actually write it over down here, which is very small part, where Q0 is actually equals to Q3. Once you have the Q3, normally I will straight away calculate the potential difference across the Q3 as well, which is equal to C equals to Q over V. Okay, I have the C, I have the Q3, I can find the V3. Once I found the V3, which is this part, I can straight away define the potential difference over there. Okay, that's the idea, and this is how you do it. Find the V3, you get 1.5 over here. Once you get 1.5, that one represent the voltage difference from this part until this part across the C3. So that means, because if you have a potential across a capacitance in series, so you can simply minus that one, you get this part. So example, power supply is 3 volt minus 1.5, you will get potential difference for this part. So in this case, you get 1.5 as well. So kebetulan equal. It doesn't have to be the same lah. If this one is 1, then that means here is 2. Okay, now I can find the C2. Maybe I can try to redraw again for you guys. So okay, if you guys remember, this one is 1.5 volt and this one is 1.5 volt as well. Once I have this one, I have V. The C is given in the question. I can straight away find the Q, charge Q2. In this case, I find the Q2 first. I got the Q2. And then once I found that Q2, I can use the same equation and then I can find the Q1. Okay, notice that Q2 and Q1 is 3 and 4.5 microcoulomb. So that means, I don't remember, I write this one as C1 or which one is C and which one is C2. Okay, maybe I'm wrong. I just write it over there. So that means the charge that going out in this junction is 3 times 10 negative 6 and 4.5 times 10 negative 6. So if you add up these two, it is actually equals to Q naught. This is what I'm saying lah. A charge, before it hits a junction, it will remain the same. Once it hits a junction, then it will separate. Okay, if you go through a junction that is divided by 3, so you divide it by 3. It doesn't have to be the same amount lah. So it depends on the weighted. So this one, example here is bigger than the up here. So if you add up over here, then you get Q naught again. Okay, so that's the basic concept of a circuit that you need to understand. Okay, please understand this part. Once you understand this part, circuit, let's say it's chapter 2, chapter 3, that one will be easy. Okay, so final answer, I just list down everything. And the question 1 to find Q and V at each capacitor. So this is one of the question that looks very simple, but when you try to solve, you have to do lots of steps. There's no shortcut, and every single time this is the main method on how to do it. Okay, I repeat how to do it. First thing, try to redraw into something that you familiar. So normally I will redraw in this form lah. So I'm used to this form, so I redraw it something like this. Every time, for every junction, I draw it like a T junction instead of daripada dia datang tepi ke apa kan. I draw it like a T junction so that when it separates, I can imagine that. Okay. So after you redraw, find the C effective first, even though the question doesn't ask. Okay, kalau soalan tak suruh cari pun kamu cari dulu. Once you find the C effective, the next step is that you want to find the Q0. So the total charge of the circuit. So this is the step that how you normally do. It doesn't have to do it every single time, but normally this is how you solve it. Okay, the tricky part is sometimes question dia tak suruh cari Q0. Question tak suruh cari C effective. Straight away dia kata find the Q at 2. But if you want to find Q at 2, basically you have to solve everything. Okay, like I said, no shortcut. Okay, question number 10. Okay, this one actually very similar to the previous question. Okay, in a way that they ask you to find the equivalent capacitance and then they ask you to find the charge at 3 and 5. So in a way, if you want to solve it, very similar concept to the previous question. Number 1, redraw. Okay, so again, redraw, double check junction. This is red junction, so we have 4 junction, 1, 2, 3, 4, 1, 2, 3, 4. Okay, before we check, I just show you how I do it. Again, I start from the positive terminal of the battery. I go straight and I see a junction. Okay, I draw the junction like a T junction. Okay, kamu semua ada lesen kan? Lesen kalau T junction is like this. So once enter the T junction, it's separated into 2. Okay, this is the T junction and then it's separated into 2. This one and that one. So I draw it up and down. So up there, you go through 2 microfarad capacitor. Okay, and then you see another junction. Okay, in this time they already draw it in T junction, so I just redraw in the same way, 5 and 6, and then it goes out, and then you go enter the junction. At the same time, the 3 capacitor to enter that junction as well. Okay, and it goes out. How to recheck? Count numbers of capacitor, 1, 2, 3, 4, 1, 2, 3, 4, same. Okay, check number of junction, ada 4 junctions, so here got 4 junctions as well, so the same. And then just recheck the value over here. Does it make sense? So down here got 3, 3, so it makes sense. So if you draw it like this, if you want to check pun senang je. Okay, if you want to find the equivalent of C effective, you can solve this one first, 5 and 6. Just have to add, and then you solve this one with the 2. I can do, because this one is series, you have to 1 over 1 over. Once I got that, I just add down here because this two is parallel. So that's the idea. Okay, kenapa dia tak nak pergi? Okay, there. Okay, find the C5 and C6. So here I just label the capacitance because the numbers of each values of capacitance different. So I just label that one as my C1, C2, C5, C6 and C3. So C5, 6, I combine these two. I just have to add. I got 11. And then 2, 5, basically this one dah combined. So I just have to 1 over 1 over that one. I got C256. Okay, C256 up here, if I want to combine, I just have to add because this one is in parallel. So I can try to show you here. Maybe I can draw it here. C256, and then down here I got C3. So that's why I just have to add because this one is in parallel. Add that one up, and then I get C effective. Okay, the next question, they want to find the charge on 3 and 5. So this one is a bit tricky because it is actually inside here. So whether you like it or not, you have to solve almost all the question. So before anything, start with finding the Q0. Okay, I just paste it over there. Okay, in this case, my bad. So in this case, you don't have to find the Q0 first, but you can find straight away, because this one, if you draw it like this, you can see it clearly. This one is the potential difference across here is 10. So that means over here and over here is actually, I just label it. Over here is 10, over here is 10, and over here is 10 volt. So I found already the voltage here, V3 is actually equals to 10. That means I can find the Q3 straight away. I got 30 microcoulomb. Once I found the Q3, again, after this, you still have to calculate Q0. So, again, if you want to solve, you really need that Q0. So, my advice, just find it first. Sometimes, even the question doesn't ask directly, there's mark given inside there. Okay, so, maybe it's best if you calculate Q0 first. So, find the Q0 using C effective. Okay, Q0 there represent the Q. Again, I draw it wrongly. It should be come from the negative, tapi it's okay lah. I just like to draw it from the positive part. It's okay. And then this Q0 actually enter the junction and it separate into two. Okay, maybe I can mangle that sikit. I just draw this one a little bit longer. So yeah. So actually the charge follows the direction of electron, but current direction normally is follow the positive terminal. It goes out from the positive terminal, it goes into the negative terminal. That one is current. Charge is the other way around, because we are talking about electron. The reason why is because actually they decided that the current must go from positive terminal to negative terminal first, and then later on, then only they discovered that actually the current depends on the direction of electron, and electron actually move the other way around. So because they already decided that current from positive to negative, they just stick with it. So we just stick with that. Okay, the reason why I draw it like this, sometimes I got confused between charge and current. So, you know, in circuit normally I draw current direction instead of charge direction. Anyway, this one, you have a Q0 going into the junction, separate into two. We already found the Q over here, which is 30 microcoulomb. So whatever the values here, I can minus Q0 minus 30, I got 256. So Q0 is 46. I minus that one, I got 16.92. So the 16.92 represent this part, 16.92 microcoulomb. It's actually Q256. And that amount is actually goes here, and then here it separates into two again. Okay, so I focus only on that part. Here, I just focus on this part, okay? Okay, I just focus on the upper part here. I think I don't want to draw that, okay? So basically, I'm focusing on this part here. So I already found that the values that going into here is 16.92. So I just redraw it over here. Okay, this is the amount of charge going into here. It comes over here and then separated into two as well. Okay, because you already you found the charge here, you have Q and C, and now you can find the V. Once I found the V, I can minus 10 minus 8.46. I can straight away get some whatever that is over here. Okay, my bad. Okay, I always got confused between using my hand and my pen. Anyway, this one is basically 10 minus 8.46, which is equals to 1.54. So because this one is parallel, so the potential difference is the same, 1.54, 1.54 over there. Once I found the V, I already have, so the C is given, so straight away I can find the Q. The question wanted to find Q5 only, so CV, substitute, and you get the answer. So like I told you previously, even though the question looks very simple, but to solve it, you have to do it step by step. There's no shortcut. Okay, I just write it over here what you need to do. Number 1, redraw. When you redraw, make sure every time you make a junction, okay, you start from positive terminal or negative. Okay, next time I think we can start from negative terminal because we are talking about car charge. So every time you start from wherever you choose, every time you hit a junction, try to redraw like a T junction. Okay, and then once you complete all the circuit, try to count again the numbers of capacitor and the numbers of junction. Does it tally up or not? The next step, obviously, most of the time you have to find the Q0. Okay, and then try to relate with the properties of potential difference. Potential difference, if you have something that is in parallel, you just have to, V is the same. Okay, so number 2, find C effective first. Okay, before you can find the Q0, you have to find the C effective first. And then number 4, try to use of Q and C. Q at junction, the separate. Remember that. So Q equals to Q1 plus Q2. This is just example. And then another, so as long as it doesn't meet any junction, so the Q remain the same. That one is the key properties. Another one is for voltage V, if parallel, V1 is equals to V2, and if in series, V1 is plus V2. Okay, so remember that for series potential you have to add and then you get the total potential. For parallel, the V is the same. Okay, if you draw it like this, you can see. Okay, if you leave it like the initial one, very unlikely you can see lah. So that's why a student normally they stuck over here. Okay, I really want to emphasize on this part because you can apply the same concept in chapter 3. So you can gain lots of marks from this chapter and the next chapter. Okay, I think for this part of the video we can stop here. Okay, next part we continue with question 11 until 15. Thank you everyone.